negative y, negative 4y, and 3y. Why? Haha. Okay, go ahead.
Because they all have a y.
Okay, next. Remove your stuff, Kevin, so India. Okay. India, why do you have these ones?
They all have x, y.
They all have x, y. Okay, next one. Why these ones, Max?
Because they all have x.
Okay. And why these?
Because they're all x squared.
Okay, so wait, leave it there for a second. So these all have x squared. So what's different about these from the x's? They have this exponent. What else do we call this? The
Square root.
squared? Not square root. Square root looks like the funky.
Yeah.
So it's a squared. It's a degree. We call it to the power.
Oh yeah.
Guys, we're going to call it degree a lot today. That's how many degrees it is. So let me ask you this. If I was going to combine all these together, and the only people that can't answer is Max, Indy, and Kevin, because they've had to talk enough, what would my answer be if I combined those things? What would I have? Let's try, because I don't think it would be that big. What's negative 2x plus 4x? Try again.
Negative to the 4.
Negative 2x
Wait, what?
and 4x I would have 2x. 2x squared. 2x squared plus x squared is
3 squared.
3x squared. 3x squared minus x squared is
2x squared.
so I end up with just 2x squared. Did I change the exponents at all?
Yes. No.
They stayed squared all the way, right?
Yeah.
The only thing I pushed together was the
Like terms.
the number in front, because these are all like terms. Okay, you can take that. All right. Can you put your stuff back in your envelopes? Okay.
I
Okay.
honestly thought she gave me like a special encouragement or something.
All right. We are, guys, we are going to be doing this in parts. So I need you to go to this page next. So you're going to go to this page next. Okay? All right. We're just going to take a few notes here, and then I'm going to give you another activity. Okay. Does the sum of 3 polynomials have to be a polynomial?
Yes.
Let's talk about what a polynomial is. Okay? So, a polynomial is, for example, 2x squared plus 4x. That would be a polynomial.
Why?
I can't combine them at all, and there's 2 terms. This, that's monomial. I don't know how to spell. So that's horribly spelled. But that's a monomial. This is a polynomial. Polynomial means it has more than one. It's 2, right? So if we had the sum of 3 different polynomials, do you think it would have to be a polynomial at the end?
Yes. No.
Or it could be a binomial, meaning this is a binomial because there are 2. Okay. All right. We're going to skip some of these for number 2. So the answer is yes. If we can disprove it, we can always come back. Okay, we're not going to do C, but I think we can do the rest of them. We're going to combine all of these 2. Max, it's like you wrote it, Max. Max says that each of the following expressions is a binomial in disguise. Show what he means by citing specific examples. Can't talk today. That would be an interesting animal name. Specific examples from each expression. So what for A, let me zoom in because it's really small. What can we do for A? Can we combine anything together to make it into a binomial, meaning it only has 2?
Yes.
Which 2 things can be combined?
5, 6.
What would I have?
11.
Now, The rule with most binomials and polynomials is you put the biggest degree first. Do I have that true here? Do I have the biggest degree first?
No.
Okay, so let's switch it. So we have negative 2a squared plus 11abc. We have the biggest degree first. So we've made that one into degree. Remember, degree is the
Oh,
exponent.
okay. I was thinking like 11. Oh.
Yep, those. So this is like the base or the leading coefficients for each monomial. That's the degree, and we call the letters the variables. Okay, some basic math terminology. Yeah, or vocab.
Is it because the 11 doesn't have a?
Doesn't have a squared anymore. No. Okay, let's look at B. B looks. The first thing I notice with B is I have some multiplication I've got to do. So let's do that. 5 times 2 is how much? 10. How many x's? It's kind of hard to read, but how many x's do you think I have there?
5.
Because I have 3 for this one and 2 for that one. Okay, so we have 5. Minus 10x to the 4th. Plus, let's say that's 3x to the 5th. What's 3x times negative 2x to the 4th? Should it be positive or negative? Negative. What's 3 times 2? 6. What's x and x to the 4th makes x to the 5th.
What are you doing?
So all I did was I multiplied the things that needed to be multiplied together.
Oh.
And remember, we multiply the leading coefficient, we add the exponents. Okay? Now I'm going to combine like terms. So let's talk about which ones are alike. I have 1, 2, 3. Do we agree that all of those are alike?
No.
Why? Because what? What makes something alike? So, do we have the same variable?
Yeah.
They all have the same letter?
Yes.
Okay. Do all the ones I underlined have the same exponent?
Yes.
Yeah, that's a 5.
5. 5? 5? Okay.
That's a 5.
It's a bad 5, sorry. It's a 5. Okay. So 10 to the 5th plus 3x to the 5th minus 6x to the 5th. How much does that give me?
8 minus 7x to the 5th.
7x. All right. 10 plus 3 is how much? 13 minus 6 is how much?
7.
7. So we get 7x to the 5th minus 10x to the 4th. Are the degrees in order? Biggest degree to smallest degree?
Yes.
5 and then 4. Yes, Taylor.
You said 10 plus 3, right?
10 plus 3 is 13.
Yes.
Minus 6 is 7.
Oh, it sounded like you said 10 plus 3 equals 7. I was like, wait, that's
Okay. We've got the next one. For D, what do we have to do for these? When I look at this, if I want to combine, we got to distribute. Jaden was just too fast. We're going to distribute a couple of times. I didn't. So I get 5a minus 5 minus 10a plus 10 plus 100a minus 100. Everybody okay with that?
Yes.
All right, I'm going to combine all of my a's. So 5a minus 10a is negative 5a. Negative, whoa. No. 5a minus 10a is negative 5a, right? Negative 5a plus 10 is, plus 100, 95a. Yep.
Okay, 5a
5a
minus 5.
minus 10a is negative 5. Negative 5a plus 100 is 95a.
Yeah, I was doing
Okay, now these ones. Negative 5 plus 10 is how much? 5. Okay, so 5 plus negative 100 is?
95.
Negative 95. Are those in degree order?
Yes.
Okay, so we're done. Yeah, well, they do. What's the first degree? 1.
Oh,
Okay, are you guys willing to skip E?
Yes.
We get it?
I don't,
Okay.
I don't want to do one behind.
Okay. Stephen writes a polynomial expression using only one variable, x, with a degree of 3. Jamie writes a polynomial expression using only one variable, x, with a degree of 7. What can you determine about the degree of the sums of Steve and Jamie's polynomials? If Steve writes an expression using only one variable and it has a degree of 3, and Jamie writes an expression using only one variable using a degree of 7, what can you determine about what they added together, about the degrees of what they added together? You can't add them together because they're different terms, right? X to the 3rd and x to the 7th, I couldn't possibly.
You could add 4 to x to the 3rd to get x.
No, you can't. If you add 4, you get x to the 3rd plus 4. What can now? Is it asking you to solve anything?
No.
It's saying, now listen to the question again. What can you determine about the degree of the sum of Steve and Jamie's polynomials? Does it ask you?
There
Okay.
isn't one.
I think you guys are misinterpreting the question.
They're gonna be
They're both multiples.
What can you determine about the degree of the sum of Steve and Jamie's? It would just be this, right?
Oh my god.
That was I wrote that.
What about the difference? It would just be,
Oh my god.
right? Sum and difference. If Steve writes another polynomial expression using only one variable x with a degree of 5, and Jamie writes another polynomial expression using only one variable with the x of 5, what can we do? What's x to the 5th plus x to the 5th, guys?
X to the
X
10th.
to the
No.
X to the 5th.
If I had, what's an apple plus an apple?
Two.
What's x to the 5th plus x to the 5th?
X to the 5th.
2x to the 5th. What's x to the 5th minus x to the 5th?
X to the 5th.
Right? If I have an apple and I take the apple away, how many apples do I have?
0.
If I could put 0x to the 5th, but if I times anything by 0, it becomes what?
0.
So I can just go right to 0, right? Right. Okay, turn it over. Okay. Find two binomials whose sum is a binomial. So let me make one up. X plus xy plus 2x plus xy. What's my sum? X plus 2x is how much?
3x.
Okay. X plus y plus x plus y. 2xy, that's correct. I said it incorrectly and Taya corrected me.
So each one of those are like each section is a binomial itself.
Yeah.
Okay.
Find two monomials whose sum is a binomial. This is easy. Can I ever combine those?
No.
Those are both a monomial, right? Monomials are separated by addition and subtraction. Okay? So that's a monomial. That's a monomial. Boom, its sum is a binomial. Because I can't combine them any further than that. They're not like terms. Monomial is all by itself. So any number, letter, or degree, as long as there's not an addition or subtraction with it. Find two binomials whose sum is a monomial. So maybe like, I don't know. Anybody got one?